Hi, this is Kenny Lee, and we're talking about work and power today. So, work for physics goes along more of a physical means, a mechanical means, where it's the force applied to the object times the distance, or we should say displacement, that force acts. And we use it in this equation right here. Work is equal to force dot D. Now that dot means something. For us, that means it's what's called a dot product. And that means force and distance have to be along the same dimension, or at very least components of force and distance have to be along the same dimension. If it's not, then we can't multiply them together. So if the force was up and the distance was sideways, they're not in the same dimension. We couldn't actually put them together. If force and distance are all in the same direction, then we can. So if I pick something up, the force is up, the distance is up, we can multiply them together to figure out the work done. But if they're not, then we can't multiply them together. So work is measured in joules, same thing as energy. And 1 joule is 1 kilogram meter squared over second squared. Power is simply how quickly you can get a job done. So it's the rate at which work is done. And power is work divided by time. And we measure power in watts. And that's one metric unit that most people know fairly well. And a 1 watt is 1 kilogram meter per second cubed. You see how these are similar? We have several units that are so similar, we decide to give them new names, like joules and watts and newtons, in order to separate them from everything else, because otherwise it'll get really confusing about the unit. So work is in joules, just like energy. Power is in watts. Now, another way that we can find work is simply the change in energy. Simply how much the energy has changed is also how much work was done on the object. So a little bit more about work. Work is a scalar. That's what that dot product results in, is a scalar. And so that means that it doesn't have a direction. So the work done on an object is what we call independent of the path that it takes. So it only concerned is about where it started and where it ended. It didn't care what you did to get there or in between those 2 points. It's just the work done on the object is from where you start to where you end. So let's say I've got this barrel here, and I pick it straight up and put it on the table. I've done work on it. The force is up and the distance is up. Now let's say I take an identical barrel, instead of picking it straight up, I roll it up a ramp onto the top of the table that's at the same height. So both barrels went from the ground to the tabletop. One was picked straight up, the other one was rolled up a ramp. Which one did I do the most work on? Well, work is force dot distance, or displacement. It turns out both of these have done the same work. On this one, you've used the maximum amount of force, but went through the smallest distance. On this one, you've gone a longer distance because you've gone up this ramp, not straight up, but along the ramp, but you didn't have to lift the entire weight of the barrel. It turns out those counteract each other, and you do the same work in either case. Because again, it doesn't matter about the path, just from where you started to where you ended. Both of them started on the ground, both of them ended up on the table, so in both instances, you do the exact same amount of work. Let's do a little calculation. So we've got a block being pushed by a force of 50 newtons. So here's my block. It's being pushed by a force of 50 newtons. And it moves a distance of 3 meters. I want to figure out the work done on the block and how much power is exerted. Well, we pushed it to the right and it moved to the right, so the distance traveled to the right. So we've done work on the block. As long as we had to do that push, we've done work on the block. So work would just simply be force dot distance. So the force is 50. The dot, as long as they're both going in the same dimension, it just means multiply. And so the distance was 3 meters. So we've done 150 joules of work moving that block. Now we did that in a time of 9 seconds. So to figure out the power, we're going to take work and divide by the time. So in this case, we've got 150 joules of work done in a time of 9 seconds. So 150 divided by 9 gives us 16.7 watts of power was exerted to move that block. All right, on this one, we're lifting a box. So we've got a box. It's 8 kilograms. We're lifting it a height of 12 meters in a time of 5 seconds. Okay, well, work is force times distance. Now we're asked for power, but we can't find power directly. We need to do something else first. So work is force times distance, and we need that because power is work divided by time. So to get power, we need work, and to get work, we need a force. We don't have a force, we have a mass. Well, the minimum force we have to exert to move that block is equal to the weight of the block. So if I know the mass, I'm going to have to go back and remember how to figure out the weight. So weight is mass times gravity, which on the Earth is 9.8 meters per second squared. And so that force is 8 times 9.8, 78.4. 78.4 newtons. Yes, I know that's the force down, but that also has to be the minimum amount of force going up in order to move the block. If we don't get at least that much, it's not coming off the ground. And anything just a hair over that means we're starting to pick it up. Okay, so let's say we've got that much force. That's our minimum. That's going to go in for F. 78.4 is our minimum force that we can possibly use. Distance is 12 meters. And so the work that we can do on that is 940.8 joules. Now, using work and energy, you're going to get large numbers. So if you happen to get a really big number, don't think you've made a mistake. You probably did it right. It's just energy is going to be a big number in most cases. The power is simply taking that minimum work that we've got there and dividing by the time. And so, divide by 5, we get 188.16 watts of power is needed for that crane to do that job in that amount of time. Well, all these have been lifting one object. What if we have multiple things that we've got to do? So on this one, we've got a person that's lifting 12 boxes in 3 minutes, one box at a time. But it takes them 3 minutes to pick up 12 boxes and put them 1.8 meters above the ground, and each box weighs 100 newtons. Well, unlike the last one where we just were given the mass, this time we are given the weight. So we don't have to figure it out. That part's given to us. So we can start off by figuring out how much work was done lifting just one box. So work is force times distance. We got the force that we have to lift, 100 newtons. We've got the distance, 1.8 meters. And again, we're just going to multiply. So that's 180 joules of work that's being done. we've got to figure out power, but that's just how much work is done to lift one. We need to figure out how much they do in total because the person actually lifts 12 boxes. So to find the total work, we need to take the work done lifting one box and simply multiply by how many boxes we lift. We lifted 12 boxes. So we're going to take 180 times 12, and that's the total work done is 2,160 joules of total work. Well, now we can figure out power, because power is work divided by time. So work divided by time will be my power. Okay, but we have one little problem here. Time is given in minutes. We have to make sure that that's in seconds. So we need to convert that 3 minutes over into seconds. Well, 1 minute is 60 seconds. And so we just have to multiply, so that's 180 seconds. Okay, so now we can put this in. So power is work, which is 2,160 divided by time, which now we've converted into seconds. So we can take that, divide, and we get a power of 12 watts. So in this case, we had to do this step because we lifted multiple boxes. If we just lifted one, we would just take the force or the work to lift one and the time to lift one and calculate it that way. And that could work too. But it was far simpler for me to just figure out the total work done with the total time to get the power. Thank you very much. Tune in again for more videos about physics. Bye.